नाही तर काय मगाशी मधनच बंद करायला मागे तर काय सुट्टी
Hello, sir.
So good morning once again. Is the screen visible to you now?
Yes, sir.
Okay. So we are talking about the elastic rebound theory. इलेस्टिक रिबॉन्ड थेरी मध्ये काय एक्सप्लेन करायचं होतं मला की अर्थच्या सरफेस वरती दोन्ही बाजूने जर प्रेशर अप्लाय झालं तर त्यावेळेस सुरुवातीला काय होतं की ऍट फर्स्ट दी अर्थ सरफेस गेट bend or get turned into wave-like structure. So in the first step, you can see here the Earth surface is more or less straight. But when the pressure is applied from opposite direction, so here the pressure is applied from opposite direction. What happens? The straight surface gets converted into curve-like structure. Now, if the pressure still continue, then what happens? The one block is converted into two blocks. They are just sliding with each other and they are separated from each other. Okay, that's why one single block is converted into two blocks. They are moved away from each other, and in this step, when the blocks are separated from each other, the energy which is stored in this block is released. आणि यावेळेस काय होतं की या अर्थच्या सरफेस वरती अर्थच्या सरफेस मध्ये जी स्टोअर केलेली कायनेटिक एनर्जी असते ती या ठिकाणी सडनली रिलीज होते आणि ज्यावेळेस एनर्जी रिलीज होते त्यावेळेस त्या ठिकाणी अर्थचे व्हायब्रेशन तयार होतात अँड दॅट व्हायब्रेशन आर नथिंग बट दी अर्थक्वेक waves or earthquake vibration. Okay, so this is the principle of the elastic rebound theory. Okay, the possible mechanism of tectonic earthquakes can be explained by the elastic rebound theory. Now what is the meaning of this? How the earthquakes, tectonic earthquakes are occurred. We have seen three causes of the earthquake. In that, the first one is the tectonic, second one is the tectonic earthquake, and the tectonic earthquakes are happened with this procedure. This procedure is considered as a elastic rebound theory, and this theory or this principle first put forward by the H.F. Reed. H.F. Reed was the scientist who gave this explanation regarding with this elastic rebound theory first. Okay, so this is about the elastic rebound theory. Now I have to share with you one video in that the elastic rebound theory is explained with the video clips animation. From that you can easily understand what is the meaning of elastic rebound theory, etc. Just wait.
Earthquakes are one of nature's most devastating events. They occur when a large buildup of stress within Earth's crust is suddenly released. Why does this happen? The answer is elastic rebound theory. Elastic rebound theory explains how energy is stored in rocks and released by earthquakes. This energy is transferred through rocks, causing them to move, which we experience as an earthquake. Earth's crust is made of giant plates of rock that float on the underlying mantle and slide past each other. The plates grind against each other along their edges in areas called fault zones. There is friction between the plates where they meet. this means that the plates don't slide freely. Instead, the rocks deform, straining until the stress is more than the rocks can handle. Suddenly, the energy stored in the deformed rock is released in the form of heat and seismic waves. The strained rocks suddenly resume their undeformed state. The whole process is called elastic rebound theory. It's like stretching out a rubber band. As increasingly more deforming force is applied, the band becomes more distorted. If the force continues, the band will break, and the stored energy will be suddenly released. Similarly, Earth's crust stores elastic stress that gradually builds up until its sudden release during an earthquake. Elastic rebound theory explains how earthquakes result in ground movement and why they most often occur on fault lines. Elastic rebound theory provides scientists with a model that allows them to forecast the probability and severity of an earthquake in a fault zone where they have sufficient historical information. The well-studied San Andreas Fault that runs through California is located where the North American plate slides past the Pacific plate. Researchers of the San Andreas Fault have determined that sections of the fault have accumulated sufficient strain to produce a major earthquake in the near future.
Now, have you understand regarding the elastic rebound theory, Gayatri? Sorry. I have got one message from the student, roll number 14, Chaitrali. Have you understand?
Yes, sir.
Okay. So we will move further. So I think last 2 minutes, the voice is not audible to you because I have muted myself. So now is it audible to you?
Yes, sir.
Okay. So after the elastic rebound theory, we are going to discuss now another point which is related with the seismograph and seismogram. Okay, so these are the two important points: seismograph and seismogram. Now, first we will see what is the meaning of seismograph. Okay, so seismograph is the sensitive instrument which records the earthquake waves, are known as the seismograph. Means this is the instrument which is used to record the earthquake waves. This instrument is considered as a seismograph. And seismogram. Now, seismogram means the earthquake waves is usually recorded on a traveling photographic paper as a series of a zigzag lines. These records are called as a seismogram. First, I will discuss with you regarding with the seismograph. Now, seismograph means it is an instrument. You generally confused in between seismograph and seismogram. When the word comes seismograph, you only remember the paper. That's why you confused that the seismograph is a record and seismogram is an instrument. But it is not like that. Seismograph is the instrument and seismogram is the paper. Now, here I have shown you the instrument is seismograph, which is used to record the earthquake waves. Now, how it working? First, this instrument is placed on a bedrock or any concrete slab with this base plate. Okay, so here the base plate is fixed with the nut bolts. Now, to this base plate, one metal rod is provided. When one vertical metal rod is provided like this, to this metal rod in suspended position, one drum is provided. Okay, in suspended position with the cable or strong thread, the one drum is provided. To that drum, one needle or marker pen is provided. Just a minute. So to that circular drum, one marker pen is provided, or instead of marker pen, another marking instrument is provided here. And this marker pen pointed on a rotating drum. So here one rotating drum is there. Just wait. The rotating drum here present at the bottom. Just wait. I have marked it with the green color. So here in the green color, I have shown you the rotating drum. Now this rotating drum continuously rotated with same speed. Okay. Now, and to on that rotating drum, the graph paper is attached. This graph paper continuously moving forward in one constant speed. So what happens if the earthquakes are happen when the vibrations develop? What happens? The base plate first vibrate, and due to the vibration of base plate, this hanging drum with the cable, this drum will be vibrated, and the marker pen which is attached to this rotating drum or to the graph paper, due to the vibration of this marker pen, so the zigzag lines are developed on this graph paper. That marking of the zigzag lines on that rotating drum or on that graph paper, that marking is considered as a seismogram. ओके. सिस्मोग्राफ आणि सिस्मोग्राम मधलं वर्किंग लक्षात आलं काय? सिस्मोग्राफ म्हणजे काय असतं की हे इन्स्ट्रुमेंट असतं. या इन्स्ट्रुमेंटला एक बेड कॉन्क्रीट प्रोव्हाइड केलेलं असतं, त्याच्यावरती एक मेटल प्लेट फिक्स केलेली असते. त्याला एक हँगिंग पोझिशन मध्ये एका मेटल रॉडनं हा सस्पेंडेड पोझिशन मध्ये एक ड्रम प्रोव्हाइड केलेला असतो. या ड्रमला एक मार्कर पेन अटॅच केलेला असतो आणि त्याचा पॉइंटर जो असतो तो या रोटेटिंग ड्रमला टच करत असतो. आता या रोटेटिंग ड्रम काय असतो की कॉन्स्टंटली म्हणजे एका 1 सेकंदाला 1 मिलीमीटर या स्पीडनं हा मूव्ह होत असतो एका सर्क्युलर डायरेक्शन मध्ये आणि त्याच्यावरती जो ग्राफ पेपर असतो तो सुद्धा त्या ठिकाणी मूव्ह होत असतो. काय होतं की ज्यावेळेस अर्थक्वेक होतो, व्हायब्रेशन्स होतात, त्यावेळेस पूर्ण हे इन्स्ट्रुमेंट व्हायब्रेट होतं आणि त्याच्या व्हायब्रेशन्समुळे काय होतं की हा जो मार्कर पेन प्रोव्हाइड केलेला असतो या मार्कर पेनमुळे काय होतं की झिगझॅग लाईन त्या ग्राफ पेपरवरती डेव्हलप होतात. दॅट झिगझॅग लाईन, त्या झिगझॅग लाईनला काय म्हटलं जातं, सिस्मोग्राम म्हणून त्याला कन्सिडर केलं जातं. आता या ठिकाणी तुमचं कन्फ्युजन होतं की एमसीक्यू मध्ये फिल इन द ब्लँक्स मध्ये हा क्वेश्चन जनरली तुम्हाला विचारलाच जातो. सिस्मोग्राफ म्हटलं की तुमच्या लक्षात काय येतं की हा पेपर, ग्राफ म्हटलं की तुमच्या लगेच लक्षात येतं पेपर आणि ग्राम म्हटलं की तुम्ही इन्स्ट्रुमेंट म्हणून लिहिता. बट इट इज नॉट लाईक दॅट. सिस्मोग्राफ मीन्स इट इज द इन्स्ट्रुमेंट and seismogram is the traveling graph paper on which the seismic waves are recorded or zigzag lines are recorded. Okay, so this is about the seismograph and seismogram. Now this is the seismogram. आता हा seismogram आहे. Here you can see if the earthquake happen or if the vibrations are developed, that vibrations are recorded here on this paper in the zigzag line. Okay, so excuse me, these zigzag lines are considered as a seismogram. So have you understand what is the difference between seismograph and seismogram? Just wait, I will show you how this seismograph is working.
We know that earthquakes cause tremors on the earth. The tremors produce waves on the surface of the earth. These are called seismic waves. Seismic waves are recorded by an instrument called the seismograph. The instrument is simply a vibrating rod or a pendulum, which starts vibrating when tremors occur. A pen or a marker is attached to the vibrating system. The pen records the seismic waves on a paper which moves under it. Trigger a mock earthquake on the table to see the seismograph in action. We can see that the pendulum tip records the earthquake on a graph sheet. In this activity, we have seen the recording of seismic waves caused by earthquakes.
So students, just wait for 5 minutes. I will continue within 5 minutes. Wait. So now is the screen visible?
Yes, sir.
So sorry again for disturbance. So have you understand what is the meaning of seismograph and seismogram? Have you got the difference between these two? Okay. So next point we are going to discuss now. Where do earthquakes occur and how often? Now, when you consider the total surface of the earth, you can't see everywhere the earthquakes. Everywhere there is a earthquake do not form. There are certain locations where the earthquakes are happened per year. Same locations are there. Okay. And why the earthquakes are happened at that same locations or that same places? The reason behind that, the tectonic activities or tectonic, there is a one theory, plate tectonic theory. When you see it in the earthquake engineering, you can again clearly understand regarding with that plate tectonic theory. But there are certain locations on the earth surface where the earthquakes are recorded year by year, and that locations form one chain or one circular pattern. So 80% of the earthquakes occur in the Pacific circumbelt. Pacific belt, circumbelt means in the Pacific Ocean, the earthquake locations are maximum. Most of these results from convergent margin activity. Now, convergent margin activities means here two types of the boundaries are there: convergent, divergent, and transform fault. Now, convergent means when two blocks comes towards each other. When two earth blocks comes towards each other, just a minute, I will show you with the drawing. You can't understand with only explanation. So three types of the boundaries are there. Suppose this is the first boundary. Just wait. I will use another color. Suppose this is the first boundary between two earth blocks where two blocks move towards each other. In the second case, what happened? The two blocks move away from each other in opposite direction. Okay. And in third case, just the blocks passing with each other in another direction. There is no gap in between these two blocks. So these are the three type of the boundaries in the earth blocks. Okay. So the first type of the boundary is considered as a convergent, where two blocks move towards each other. It is considered as a convergent. In the second block, two blocks go away from each other. It is considered as a divergent. And in third type, the only slipping is there, which is considered as a slip fault. Okay. Only the blocks are slip away to each other. There is no gap in between these two blocks. But in the previous two, that is in the convergent and in divergent, the gap will be found in between two blocks. So in the Pacific Ocean, the convergent boundary is there. One block, two blocks move towards each other. Now, when two blocks move towards each other, what happens? Suppose this is the one block and this is the second block. Two blocks move towards each other. Now, after moving, what happens? At the next step, just a minute, I will show you towards the left hand side. Suppose this is the first block and this is the second block. Now one block goes beneath the second block. ज्यावेळेस दोन्ही ब्लॉक एकमेकांकडे डायव्हर्ट होतात एकाच डायरेक्शनकडे, अशा वेळेस काय होतं की एक ब्लॉक दुसऱ्या ब्लॉकच्या खाली जातो. आणि ज्यावेळेस ही मुवमेंट सुरू असते त्यावेळेस या एरियामध्ये असे व्हायब्रेशन्स तयार होत असतात. दॅट व्हायब्रेशन्स आर कन्सिडर्ड ॲज ए अर्थक्वेक. ओके, आता ही जी सगळी थेअरी आहे याला प्लेट टेक्टॉनिक थेअरी म्हणून कन्सिडर केलं जातं. अर्थक्वेक इंजिनिअरिंग म्हणून पुढे एक सेपरेट सब्जेक्ट तुम्हाला स्टडी करायचा आहे. त्याच्यामध्ये ही थेअरी तुम्हाला पहिल्या युनिटमध्ये व्यवस्थित पुन्हा समजेल. आता जर ही थेअरी डिटेलमध्ये सांगायचं झालं तर याला 2 ते 3 लेक्चर्स लागतात. ओके, सो आपल्याला फक्त काय लक्षात ठेवायचं आहे की अर्थच्या सरफेसवरती मॅक्झिमम अर्थक्वेक्स कुठं होतात, तर पॅसिफिक ओशन मध्ये मॅक्झिमम अर्थक्वेक्स होतात. कारण का त्या ठिकाणी कॉन्व्हर्जंट टाईपची बाउंड्री असते, म्हणजे 2 ब्लॉक्स एकमेकाकडे एकाच डायरेक्शनकडे मूव्ह होतात. अबाउट 15% ऑकर्स इन मेडिटेरियन एसेटिक बेल्ट, म्हणजे 100% पैकी 80% पॅसिफिक ओशन मध्ये होतात. मेडिटेरियन एसेटिक बेल्ट म्हणून सेपरेट अजून एक बेल्ट आहे, त्या ठिकाणी 15% होतात. आणि रिमेनिंग 5% आहेत ते कुठे होतात, इन द इंटेरियर ऑफ प्लेट्स, म्हणजे जे या वेगवेगळ्या प्लेट्स आहेत. आता प्लेट्स म्हणजे काय, पुन्हा तुम्हाला शॉर्ट मध्ये एक्सप्लेन करतो. तुम्ही जर ही अर्थ कन्सिडर केली तर ही अर्थ वेगवेगळ्या प्लेट्सना तयार झालेली आहे, म्हणजे लाईक फुटबॉल, की अशा प्लेट्स एकमेकाला अटॅच झालेल्या आहेत. ओके, वेगवेगळ्या प्लेट्स एकत्र येऊन हा अर्थचा सरफेस तयार झालेला आहे. आणि अबाउट 95% जे अर्थक्वेक्स होतात ते या प्लेटच्या मार्जिनवरती होतात, म्हणजे ज्या ठिकाणी 2 प्लेट्स एकमेकाला अटॅच होतात. ही जी मार्जिन असते किंवा बाउंड्री असते, या बाउंड्रीवरती 95% अर्थक्वेक्स होतात. आणि रिमेनिंग 5% अर्थक्वेक्स आहेत ते या प्लेटच्या आतमध्ये कुठंतरी होतात, म्हणजे लँड एरिया. Suppose the Koina is the best example of this 5% earthquake. In land area, the 5% earthquakes are occurring. Okay, more than 1,50,000 earthquakes strong enough to fail are recorded each year. म्हणजे पर इयर जवळपास 1.5 lakh earthquakes रेकॉर्ड केले जातात थ्रू आउट दी वर्ल्ड. ओके, so throughout the world 1.5 lakh earthquakes are happening all over the world. Okay, so this is about the earthquake locations. Just wait, I will share with you another one video. Global earthquakes. Yes. त्यामध्ये या व्हिडिओमध्ये काय एक्सप्लेन केलेलं आहे की कलर कोड्स यूज केलेले आहेत. डेप्थ वाईज क्लासिफिकेशन मध्ये. आणि हे सर्कल्स काय इंडिकेट करतात, सर्कल जर बघितले तुम्ही तर त्या ठिकाणी सर्कलचा साईज सुद्धा कमी जास्त आहे. कमी एकदम स्मॉल सर्कल असेल तर त्याची मॅग्निट्यूड 7 आहे. मीडियम सर्कल असेल तर त्याची मॅग्निट्यूड 8 आहे. लार्ज जर सर्कल असेल तर त्याची मॅग्निट्यूड किती आहे, 9च्या जवळपास त्याची मॅग्निट्यूड आहे. ओके, सो जस्ट वेट, ड्यू टू इलेक्ट्रिसिटी problem I have disconnected from my PC. I think it is not visible to you. Just wait, I will reconnect with my laptop. So just wait for 1 minute, I will reconnect with my network. Now is the screen visible to you?
Yes, sir.
So here you have to understand that the color code is used for the various depth, shallow, deep and intermediate type of the earthquakes, and the diameter. Small diameter means small magnitude earthquake. As the diameter of the circle continuously increasing, it means that there is a large magnitude earthquake. Intensity of the earthquake is continuously increasing if the diameter of the circle is increasing. Okay, so just wait. I will replay it. Side by side, look towards the left hand bottom. Years are given. Now here, when you see here, the whole, the locations from whole words is given here. Now, when you look here, in the Pacific Ocean, one ring-like structure is formed. Okay, so this is the ring-like structure where the earthquakes are maximum in number per year. You can say that on this track or on these locations, earthquakes are repeated. So this location is considered as a ring of fire. Okay, so this location is considered as a ring of fire, and about 85% earthquakes occurred here on this ring of fire, that is in the Pacific Ocean. Now remaining 15%, okay, so remaining 15% locations are in trans-Mediterranean. So here towards the right hand side, I have given these are the locations towards the left and right hand side where remaining 15% earthquakes are occurring, and the 5% occurs on the land areas. Okay, so these are the some land areas where the 5% earthquakes are located. Now, when you look here in India, where in the Maharashtra, one circle is given. So this circle indicates the Deccan Trap activities, okay, tectonic activity, earthquake activities. So in the Western Maharashtra, Western Maharashtra is also considered as an earthquake area due to the large reservoirs like Koyna and Chandoli, etc. Now, how these reservoirs are responsible for such a type of the earthquakes, that we are going to discuss in the next point, that is reservoir induced seismicity. In that point, I will explain it very well. Okay, so here now it is almost 12. So I will stop discussion regarding with these earthquake. Now we will continue it in the next lecture. Remaining points are there, like next points of this chapters are the earthquake waves, its characteristic, etc. That we will be discussed in the next lecture. Okay, so I will end this meeting now.